Mechanical gears. Mechanical gears are toothed wheels used to transmit power and motion between rotating shafts. They work by meshing with each other to alter the speed, torque and direction of mechanical energy. Gears can be of different types such as spur gears, helical gears, bevel gears and worm gears, each suited for specific applications based on their design and configuration. They're crucial components in various machines, from simple devices like watches to complex machinery like automobiles and industrial equipment. These are some different types of gears used in various mechanical systems. 1. Rack gear. A rack gear is a type of gear that doesn't form a complete circle like typical gears. It's a straight or linear gear with teeth cut into a flat surface. The teeth of a rack gear mesh with the teeth of a pinion gear, a small cylindrical gear, to convert rotational motion into linear motion or vice versa. Rack and pinion systems are commonly used in steering mechanisms in vehicles, CNC machines, and various other applications where linear motion needs to be converted from rotational motion or vice versa efficiently. 2. Spur gear. Spur gears are cylindrical gears with teeth that are cut straight and extend radially. They mesh with other spur gears to transmit power and motion between parallel shafts. Spur gears are commonly used in various applications due to their simplicity, cost-effectiveness, and efficiency in transmitting rotational motion. They're found in devices like gearboxes, clocks, engines, and many other mechanical systems where a simple and direct transfer of power is required. 3. Internal gear. Internal gears have their teeth cut on the inner surface rather than the outer edge like external gears. They mesh with other gears where the teeth are located on the outside diameter. Internal gears are often used in planetary gear systems, gear pumps, and other mechanisms where space constraints or specific design requirements necessitate gears with teeth on the inside circumference. They're effective in transmitting motion and torque between shafts that are located inside or within a confined space. 4. Worm gear. A worm gear consists of a worm, a screw-like gear that meshes with a gear wheel or worm wheel. The worm has a spiral thread that engages with the teeth of the wheel, allowing for a right angle transmission between the axes of the worm and the wheel. Worm gears are known for their ability to provide high gear reduction ratios and are widely used in applications where a large speed reduction is necessary. They're found in various mechanisms such as conveyor systems, automotive steering, elevators, and other machinery requiring high torque and speed reduction. 5. Helical gear. Helical gears are a type of gears with angled teeth cut in a helix shape around the gear's circumference. This helical design allows for smoother and quieter operation compared to spur gears, as they transfer power more gradually and evenly. They're commonly used in various mechanical systems due to their efficiency, reduced noise, and ability to handle higher loads. 6. Herringbone gear. Herringbone gears are a type of double helical gears where two opposing helical gears are placed side by side, resembling the letter V or an inverted V. They have angled teeth that provide smoother and quieter operation compared to straight-cut gears, as they help to cancel out axial forces and reduce vibration. Herringbone gears are commonly used in high-power applications where precise and smooth gear operation is crucial, such as in heavy machinery, automotive transmissions, and industrial equipment. 7. Bevel gear. Bevel gears are a type of gear with cone-shaped teeth used to transmit motion and power between non-parallel intersecting shafts. They have straight or curved teeth cut along the conical surface and are primarily used to change the direction of rotation. Bevel gears can be classified into straight bevel gears with straight teeth and spiral bevel gears with curved teeth for smoother operation and less noise. They're commonly found in applications like differential drives in vehicles, hand drills, and other machinery requiring power transmission between intersecting shafts at an angle. Each type of gear has specific uses and applications depending on the mechanical system's requirements. Thank you for watching.